Welcome to my channel. Let us discuss another problem in electrostatics which is very important. It is about earth connection, the problem of earth connection in electrostatics. Now, it is like this. We have a three concentric thin conducting spherical cells A, B and C. These are three conducting spherical cells. The cells A and C are given charges plus Q and minus Q respectively. That is, A is given a charge plus Q and C is given a charge minus Q. Cell B is earth connected. This is cell B, it is earth connected. We have to find out the charges appearing on the surface of B and C, that is, charges that appears on the inner surface of B as well as outer surface of B, inner surface of C as well as outer surface of C. Now, how to solve this problem? We shall discuss on the line of these important points. I hope if the students understand these 5 points, they can solve all problems related to electrostatics, related to earth connecting conductors in electrostatics. Now, first point is that potential of earth conductor is zero. If you connect, because earth is a zero potential, if you connect a conductor to earth, it attains zero potential because of its vastness of the earth. Because as you know, C is equal to Q by B, B equal to Q by C, and capacitance of earth is very, very large. So we can consider earth to be at zero potential. So all conductors, when connected to earth, are at zero potential. So the potential of conductor or cell B is zero. Second point, conservation of charge not applicable to earth connected conductor. We cannot apply the principle of conservation of charge to earth connected conductor because charge can flow to the surface of earth without changing the potential of the earth. So we cannot apply the principle of conservation of charge to earth connected conductor. Third point, Gauss law is to be applied to know the charge on the inner surface of conductor. How can we know the charge on the inner surface of the conductor B and inner surface of conductor C, so that you can find out the potential on the conductor surface B. Now, fourth point, consider a charge on the outer surface of B. If you cannot think of that the charges have flown to the earth and the outer surface have no charge, because the conductor B is under the influence of another conductor having a charge minus Q. So you cannot consider that no charge is there on the outer surface because it is connected to earth, because it is under the influence of charge minus Q. Now, fifth point, charge is conserved for the conductor C because the conductor C is not earth connected. So we can apply the principle of conservation of charge to the conductor C. Let us start. Now, with these 5 points in mind, we shall find out the charges distributed on the inner surfaces of the conductors. Now, it is given the charge on the surface, that is cell A, is plus Q. So, how to find out the charge on the inner surface of B? Because if you consider a point on the interior to the surface B, interior to the cell B, and take a Gaussian surface, they are not showing the fully drawn. The intensity is 0 here. Intensity of electric field 0 inside the conductor under static condition. Now, if you apply Gauss law, E dot ds, surface integral is the flux, is equal to total charge of an epsilon 0, permittivity of free space. Now here, since E equal to 0, here it implies that the sum of charges included by the Gaussian surface, the total charge included by the Gaussian surface must be 0. And because this charge is plus Q, so the charge that develops because of induction on the inner surface of the cell B must be minus Q. Now, similarly, the charge on the inner surface we can find out, inner surface of cell C we can find out. Now, another point is to remember that it is given here that you cannot consider the charge on the outer surface of cell B to be 0 because of the presence of the conductor C, which has a charge. So let it be Q dash, let it be plus Q dash. Now the charge on the outer surface of cell B is assumed to be, say, Q dash. Now using Gauss law, the charge on the inner surface of cell C must be equal to minus Q dash. Now next point is, what is the charge on the outer surface of cell C? Because for the conductor C, since it is not earth connected, we can apply the principle of conservation of the charge. That is, on the outer surface of C, the charge must be minus Q plus Q dash, so that the total charge, that is the charge on the inner surface and the charge on the outer surface, is equal to minus Q dash plus Q dash minus Q, so that the charge is conserved. Now, what do we know using Gauss law? The charge on the inner surfaces of the cells are determined, and all these points are followed. Now, very important is that whatever be the charge distributions, the conductor B, the cell B, as it is earth connected, must have zero potential. So if you find out the potential due to all charge distribution on the surface B, it must be set equal to 0. From that you can find out the unknown parameters, that is Q dash. Now let us see one by one. The potential on the conductor B, cell B, due to the charge plus Q is, say, V1 equal to K, charge is plus Q, by distance is 2r, because for external point the charge appears to be concentrated at the center. So it is Q by 2r. Now, the potential due to the charge on the inner surface minus Q, the potential due to the charge minus Q on the cell B is equal to V2 K minus Q by 2r, and the potential due to the charge plus Q dash is equal to V3 K Q dash upon 2r. Now the potential on the surface B due to the charge on the inner face of the cell C is V4 equal to K minus Q dash. Similarly, the charge appears to concentrate at the center, so distance is 3r, and V5 potential due to the charge minus Q plus Q dash on the outer surface of cell C on the cell B is equal to K minus Q plus Q dash upon Cr. So the sum of this potential V equal to V1, V2, V3 plus V4 plus V5 must be equal to 0 because it is earth connected. Now Q by R taking common, K by R taking common, we have plus Q by 2 minus Q by 2 plus Q dash by 2 minus Q dash by 3 minus Q by 3 plus Q dash by 3. So that minus Q by 2 plus Q by 2 cancels out. Q dash minus Q by 3, Q dash by 3 plus Q dash by 3 minus Q dash by 3 got cancelled. So it is equal to K by R, Q dash by 2 minus Q by 3 is equal to 0. Now Q dash equal to 2 by 3, Q dash equal to 2 by 3 into Q. That is the value of Q dash. Q dash in terms of Q equal to 2/3 of Q. Now once you know the value of Q dash, we can find out all the charges on the different surfaces of the cell. That is, say on the outer surface of cell C, this is minus Q plus Q dash. This is minus Q plus 2/3 Q, that is minus 3Q plus 2Q minus 1/3 Q, minus 3Q plus 2Q. Inner surface of cell C, that is minus Q dash. Minus Q dash means minus 2/3 of Q. And on the outer surface of cell B, outer surface has the charge plus Q dash, that is 2/3 Q. Inner surface of cell B, that is minus Q. And the outer surface of the cell A is equal to plus Q. Outer surface of cell A is plus Q. Now this is how we can solve all the problems relating to earth to conductor in electrostatics. And important point, all these 5 points that I have written must be taken into consideration while solving a problem of earth connected conductors in electrostatics. And this is a very important concept. Using this principle, I hope you can solve independently the other related problems. I hope this will benefit you appearing for the appearance of entrance examination. Thank you.